All right, thanks for tuning in. Brandon Clayton, the Algebra Guy. And as you see on your screens, today's lesson will be how to add and subtract polynomials. So let's jump right into what we're covering today. All right, so by the end of this video, you'll be able to do the following teaks or the following skills. Identify polynomial, monomials, binomials, trinomials. Determine the degree of polynomials. Add and subtract polynomials and monomials, and evaluate polynomials for a given value. So let's figure out how to do that now. Identifying polynomials, monomials, binomials, and trinomials. Now, if you're familiar with those prefixes bi, mono, and tri, it should be pretty easy for you because you can realize that mono is 1, bi is 2, and tri is 3. But 1, 2, and 3 what? So early in this course, we learned that a term is a constant or the product of a constant. So a term, let me illustrate this real quick just as a reminder. So a term could be something like 3, or it could be some constant times a variable, right? 3x or 3x squared. All these are terms because they're multiplied to something else like a product. But all these are individual terms. When it is of the form ax to the m, where a is a constant and m is a whole number, is called a monomial. So a monomial is what you see right here. You got some number to the variable times a variable to some power, and this is to the power of 1. A monomial or a sum and or difference of monomial is called a polynomial. So if you add or subtract another term like this, we're going to call that a polynomial. So we'll get into some more examples like that here in a second. So here's an overview. So monomial, let me shut this down 1 second. So a monomial, as you see, is just when you have one term, 5, 4b squared, and negative 9x cubed. So look at these. You would have thought that without us going into much detail that 4b squared may have been a binomial because you see two things there. You see a number and a variable, but they're all being multiplied, so we see that as one term. It's kind of like wrapping up a lot of sticks together. They're bounded by their multiplication, and so we call that one term. The only way you're going to separate more than one term, and watch this, is through adding or subtracting. Multiplying and dividing is going to make those things one unit still. So we see this as monomial. So even though you have a negative, a 9, an x, a cube, all these, this is being multiplied. Negative 9 times this x cubed is just one term. A binomial obviously has two terms, and notice they're being separated by a subtraction or a plus sign. Trinomial, as you can imagine, is separated by two operations, so you have three terms. And a polynomial could be any variation. All these are considered polynomials, so they could be any variation of those that we just talked about. Now, let's practice a little bit. Let's determine whether each polynomial is a monomial, binomial, trinomial, or some other polynomial that we haven't discussed. So first, let's look at this one. Letter A. Is that a monomial, binomial, or trinomial? Well, let's look at the different terms. We have one term here because x squared, there's no more x squares in here, so that's one term. We have an x, there's no more x's in here, so that's a separate term. And we have a 9. There are no more terms that just have a number. So these are three different terms separated by a subtraction sign. So this we're going to call a trinomial. Let me see if I can write that out just for visual purposes. I'm going to call this a trinomial. And I'm going to just kind of abbreviate. I guess I'll write the whole thing, trinomial. There we go. And this one has no operations plus or minus, right? So you see the negative, but there's not an operation connecting another term. These are all being multiplied together. So what do you think this is? I'm hoping you're saying monomial, right? So monomial. Let me switch colors here. And look at this long baby there. Whoa. That's a lot of terms. So we got to the fourth, to the third, to the second, to the 1, understood to be 1 there, and to the 0 power. These are all different terms, separated by subtraction or addition. So yes, there are 1, 2, 3, 4, 5 different terms here. Now we don't have a word for 5 for polynomials, so we're just going to call this a polynomial. This is that one that says where we just have other, right? Just have a other. So I'm just going to call this a polynomial. So if you're taking notes, you want to write that down there. What about this one here? These are two different terms separated by a subtraction sign. This is going to be a binomial. Binomial. And this is just one little lonely guy. Poor thing. This is a monomial. So you see no addition or subtraction here. No. I don't want to write all that. But okay, you're forcing me to. Monomial. There we go. All right, so monomial. That's how you are going to identify your trinomials, binomials, and all polynomials. The degree of a term is of its exponent and its variable. What about degree? So I talked about in the introduction, we're going to learn what the difference is when you say what degree is this polynomial. What do you mean by degree? So let's look at a chart to help us see that. And let's break down one piece at a time. So let's start with this first part up here, this first row. So we have a monomial of 5. What degree is that? Well, that's 0. Well, how do you know that? Because look at its exponent. What exponent? Exactly. It has no exponent. It has no. If it has some x to the 0 power. So what is x to the 0 power? You want to say 0, I know, but actually it's 1. Anything to the 0 power is 1. And 1 times 5 is 5. So this number actually still is 5. And you can assume there's an x to the 0 there. And a 0 means this is a 0 power. What about this one? Well, the biggest exponent in this monomial is 2. So it's going to be 2. We're going to take the biggest exponent in each one. And the biggest one here is 3. And again, this is just a number. So we can assume that there's some variable to the 0 power. If you really want to argue it, you could and say, well, there's something there to the 0 power. What about binomials? So let's look at, let's do orange. So let's look at this binomial, b plus 1. What's the exponent that's greatest? Well, it'll be 1. Because on the b, there's assumed to be a 1. We don't write it. Just like we don't write the 1 in front of the b. We understand it's 1b. So the exponent tells us the greatest exponent between this b and this 1 is a 1. So we're going to say this is a polynomial of 1. The greatest exponent here on this a is a 1. So we're going to say this is a 1. The greatest exponent here is a 2. And between this 3 and a 2, the greatest is a 3. So we're not going to add those together. We're just going to take the biggest one. So we're going to say this binomial is a degree of 3. So that way we know the biggest exponent here is 3. What about trinomial? Trinomial is the same thing. You take the biggest, the term that has the greatest exponent, and we call that the degree of that polynomial. So in this case, it's 2. As you can see, we have a 2 here. A 2 here, so we call this one 2. A 4 is the greatest here, so this is going to be 4, and a 4 is the greatest here, and this is going to be a 4. So hopefully that's starting to make sense. But just to finish off, what if we have just random polynomials here? So we're still going to say this is the 1, that's the biggest exponent in that expression there. The biggest one here is a 2, and the biggest here is a 4. So hopefully you get that idea. So the question really is, what is the degree of this polynomial? And you can answer that question now by just simply finding the term with the greatest exponent. All right, so let's find the degree of these polynomials. So I will pause it here, and on the scratch piece of paper on your notes page, answer this question. A, B, C, D, and E. What are the degrees of each one of these? So what's the degree of 4x? Degree, yeah, just remember that that's the highest exponent value for that term. Well, this is just 1, I'm hoping you said, right? So just 1 there would be sufficient. Why? Because a 1 will tell me that this is the greatest exponent here. Well, the biggest exponent in this expression is 3. So this is going to be a 3. And what about this one? It's just a number. Well, that's going to be 0. There's nothing there. I could, like I said, write x to the 0 to show that there's a 0 there, but hopefully you get that. What about this one here? The biggest is a 2, and so we're going to call that a 2. And here we have a 1, so the degree of that expression is a 1. Now, I put a note down here to remind you that This is why it's preferred. This is one of the reasons it's preferred when you're writing an expression, a polynomial in particular, to keep the exponents in descending order. So I said that here in descending order, because it becomes easy to see what the degree is. You just simply look at the one just furthest to the left, right? Furthest to the left. As you see, the exponents are normally furthest to the left and in descending order. So you start with your highest and then you go down to the lowest. This is called standard form. Anytime you put it in that form, we're going to call that standard form of that polynomial. Now let's go ahead and add and subtract polynomials. We're going to keep in mind how to combine like terms. Well, what is a like term? Like terms have the same exponents attached to them. Like for instance here, we have an x squared and an x squared. So it's easy to combine the coefficients 17 and 6 because they're both x squares. It's like me saying 3 pencils plus 2 pencils. Well, they're both pencils. We just can say 5 pencils. But we can't say 3 pencils and 2 pens is 5. Well, we can't say anything because they're two different terms. We can't say they're collectively the same of anything. So since we know these are both x squares, we can collect those coefficients 17 and 6 and say 17 plus 6 gives me a 23. So I know that's 23x squared. Subtracting is the same way. If those coefficients, the variables are the same, we know we can add or subtract the coefficients. So this 11 minus a negative, we know that minus a negative is going to become a positive. So this becomes 11 plus 8, giving us 19 n. Let me reset my pen here. And I want a different color. All right, let's do our last one. We have a squared plus 4b squared minus 7a squared. So we can collect our like terms. Notice that we don't have all like terms. They're all squared, but that doesn't make them like terms. A squared is like a squared. So I can collect or combine those coefficients. In front of a squared, I have a 1, and I have a minus 7 in front of this one. So I can say, what is 1 minus 7? Well, that is negative 6a squared. So I simplify that one like that. Now I have left 4b squared. And there you go. And typically, if given a choice, we usually like to put our alphabet in the right order too, just because it makes sense, right? A goes before B if they're not the same. So we just make like X comes before Y. So just get used to seeing that because that's pretty common as well. And it also helps you when trying to organize your information for later. All right, what about these? Adding and subtracting polynomials. So on a scratch piece of paper on your notes, try this one before I work it. Remember, we're combining like terms, not just numbers. Make sure they're like terms. So if I'm going to combine like terms here, I'm going to realize that for my x squares and x squares are like terms. So 4 plus 3 gives me 7x squared. I like to cross these out to remind myself that I've combined those already. And I have an x and an x. They can go together. So I combine those coefficients, negative 5 and negative 8. Negative 5 plus a negative 8 gives me a negative 13. And that variable is x. I'm going to cross those out to remember I've done that. And I have a 1 minus 9. 1 minus 9 would give me a minus 8. And that's it. So the only thing I want you to check here is that you're recognizing what like terms look like and knowing how to add and subtract those coefficients. Now, for difference, this is one you need to be careful of, because when we subtract, we have to remember to subtract the whole quantity. For instance, this one says 7u squared, let me put this away, 7u squared minus 5u plus 3 minus 4u squared minus 2. So what are we really subtracting here? Well, we're not subtracting just 4u squared. We're subtracting 4u squared minus 2, the whole quantity. So what difference does it make? Well, the difference is this. When you rewrite this, and I encourage you to do so when you first start doing these, you need to, well, start out with this first part being the same, plus 3. We need to make sure we distribute this negative to both terms. Why? Because we're subtracting all of it. So this becomes a negative 4u squared and a plus 2. Because negative, this is the negative 1 you can assume here, times a negative 2 is a positive 2. Now it's time that I can combine like terms. So I can combine my u squares. 7 minus 4 gives me a 3u squared. So I can cross those out. And do I have any more u's? Nope, I just have that one u, so I'm going to bring that down. Notice I'm keeping it in descending order of exponents. So cross that out. And I do have two numbers that are by themselves, 3 plus 2, which is a 5. And I can combine those. And there's my simplified expression after working that. All right, let's go to our next problem. All right, so this one's asking us to subtract, but it's telling us in the words and not simply drawing a minus sign. So be careful here as well. M squared minus 3m plus 8 from 9m squared minus 7m plus 4. The temptation is to simply replace that from and put a minus sign, but that wouldn't be right because we got to remember we're taking this away from that. So we have to start with what we have already and then take this away from it. So if you're first starting out working these, I would be sure, or even if you've been doing these a while, I'll be sure to rewrite it so that you can clearly see what's really going on here. So I'm going to rewrite my 9m squared. All right, I'm trying to write my 9m squared. Let's give that a break. All right, so let's try to write our 9m squared. So it's going to be a little sloppy because I need to use my mouse now. 9m squared minus 7m plus 4. And I'm going to subtract all of this stuff. Now, when I subtract it, what I'm really doing is putting a minus sign, parentheses, all of this stuff. So here's my m squared minus 3m plus 8. Now I'm having to use my mouse again because my writing tool is not wanting to cooperate. So it looks like child's writing, but hopefully you can still follow along. Now remember, this minus is going to subtract everything, not just this m squared. So I'm going to rewrite this to reflect that I'm subtracting everything. So I'm going to write my 9m squared again. And I'm going to try to use my writing tool to see if it helps me out. So 9m squared minus 7m nope, not wanting to work there, plus 4 minus m squared. And so I'm going to make sure I distribute that here, distribute it to this negative 3, and distribute it to the 8. So negative times a negative makes that 3 a plus 3m and a minus 8. Minus 8. There we go. Now I'm going to combine my like terms. Going to switch colors to show that. Do I have any other m squares? I sure do. I have a 9m squared and a minus 1, a negative 1. So that's simple. Going to be 8m squared. M squared. Crossing those out. Negative 7 plus 3. So these m's are like terms. So that makes that a negative 4. When I do negative 7 plus 3, negative 4m. There we go. And then we have 4 minus 8. So 4 minus 8 gives me a negative 4. And that's it. Notice my exponents are in descending order because that standard form makes it a lot easier if you learn to do it that way. All right, what if I wanted to evaluate? Evaluate simply means I'm just going to plug this number in in place of where my variables are and solve it. So let's start out with putting 3 in place of x. What would that look like for a polynomial? What I could do, again, I'm going to see if I can use my nifty pen here, 3, and then I can do 3 squared. So that's going to be minus 9 times my 3, and then plus my 7. So what you can see is all I did was replace my 3 or my x with a 3. Now I just simply solve it. Now be careful to remember PEMDAS here, and particularly that we need to do exponents before we multiply these. Don't make the mistake of saying 3 times 3 is 9 and then 9 squared. So I need to do my exponents first. So 3 squared is 9, and then 9 times 3 is 27. Now in this case it wouldn't matter because we got all 3's. 3 times 3 times 3. So this is going to be our 27. And then minus 27, right? Because 9 times 3 is 27. And then plus 7 more. So that becomes easy. That's just going to be 7, right? Because 27 minus 27 is 0. So that's what happens when I put a 3 in there. What would happen if I put a negative 1? Let's try it. So let's rewrite it. 3. And I replace this x with a negative 1. And I'm going to square it. Minus, let's see, we're going to put a negative 1 here. Plus 7. So again, I'm going to square this negative 1 first, which is really simple. Negative 1 times negative 1 is a positive 1. 3 times 1 is 3. This is going to be negative 9 times negative 1, which is a positive 9. So this turns into a plus 9. And I have a plus 7 after that. So that becomes 3 plus 9 is 12. 12 plus 17 is 19. There's our answers. One more. What if I had a word problem where they ask you to evaluate? This one should be a gimme. Anytime they ask you to evaluate, you're simply just plugging the number in and solving it. When I was doing math as a kid, we called it plug and chug. The polynomial negative 16t squared plus 300 gives the height of an object t seconds after it's dropped from a 300-foot tall bridge. Find the height after t equals 3 seconds. Sounds complicated, but really just asking you to evaluate this expression when t equals 3. Because this expression shows what's happening when they drop this ball. Matter of fact, if I went a little further just to illustrate that, and I drew a graph, and kind of try to think about what this will look like, let's say they're at 300 feet up here. Let's say this is 300 feet. And they drop the ball. It looks like, because this is square, this is going to be a parabola, and it's negative, so it's going down. So it's kind of going down on the curve. Something like that. So they want to know what's going to happen after, when in 3 seconds. Where is it going to be? How high is it going to be at 3 seconds? So all we need to do is replace that t with the 3 and solve it. So let's see if I can do that. So we put our negative 16. Alright, it's not want to let me write there. And then instead of t, what are we going to put? A 3, of course. So we're going to write a 3. And square it, and then add 300 to it. And now we just put in the calculator or just solve it. And you probably need to use a calculator here. Let's see. 3 squared. Remember, don't do 16 times 3 because that's not the order of operations. It's exponents first. 3 squared is 9. 9 times 16, or negative 16 plus 300. So I'm going to use my calculator here because that number is bigger than I can figure out in my head. So let me get my nifty calculator out and do just that. Alright, let me get control of my calculator. Alright, here we go. So I'm going to put in, I already know this is 9 times negative 16, so I'm going to go to my 9 times 16. And I know this is negative. Let's see if I can find a negative sign on here. It's supposed to be negative, but I can't find it. But so what I'm going to do is just, oh, here it is right here. negative. So I'm going to add that negative 144 plus 300. And it gives me 156. So what is that 156 telling me? That's telling me what the height's going to be at 3 seconds. It's going to be 156 feet in the air. So 156 feet in the air. And that does it for us, ladies and gentlemen. Did we accomplish our goal? You better believe it. We identified what polynomials, monomials, binomials, and trinomials are. We talked about what degrees are and how to recognize those in polynomials, how to add, subtract polynomials and monomials, and evaluate is what we did last. So good job, and thank you very much for tuning in. My name is Brandon Clayton, the Algebra Guy, and I'll see you next lesson.